Welcome to Lesson 2.8. Today we're going to talk graphing linear and absolute value inequalities. Go ahead and pause the video and get these two terms written down before moving on. Our first vocab term is a linear inequality. That resembles a linear equation but has an inequality symbol instead of an equal sign. Second term is a boundary. That's the equation of the line, either solid or dashed, that separates the shaded region from the unshaded region. So how to graph an inequality? First of all, solve for y. Have y on the left side of the inequality symbol, everything else to the right. Then you're going to graph the equation using an equal sign instead of an inequality. So you would graph it just like you would graph any other line. From there, you determine whether your boundary line is solid or dashed. Basically, if it's got the or equal to on it, it's a solid line. If it doesn't, then it's dashed. And then we determine if the shading is above or below our line. Less than or equal to means we shade below. Greater than or equal to means we shade above. So these 4 steps will tell us how to graph an inequality. So here's our first example. We've got x plus 4y is greater than 2. So again, first thing we do, solve for y. So I got to subtract x from both sides. 4y is greater than negative x plus 2. Divide by 4, divide by 4, divide by 4. Okay. So this is my inequality. So what I do to graph the boundary line is I change it to an equation. So I just graph y is equal to negative 1/4 x plus a half. So I start at a half for my y-intercept, negative 1/4, so down 1, right 4. Or I could go up 1, left 4. Okay. Now, when I connect these here, it should look something like this. Now, the next thing is I can determine whether it's a dotted or solid line. And that comes from my inequality right here. It does not have the or equal to on it, so I need to make it a dashed line. So there, now it's a dashed line. And finally, for shading, I look at the inequality as well. It's a greater than. Greater than means we shade above. So we've got a dashed line shaded above. Our second example, graph 3x plus a half y less than 2. Again, I solve for y, subtract 3x from both sides. I get 1/2 y less than negative 3x plus 2. Multiply everything by 2. Y is less than negative 6x plus 4. Okay. So again, graphing this line, my y-intercept is 4. My slope is negative 6, so I go down 6 over 1. Down 6 over 1. Okay, so I can connect these with a line best as I can. And now from there, I look at my inequality. It does not have the or equal to on it, so it'll be a dashed line. So I can go and just make this a dashed line instead of a solid line. Again, that's because it does not have the or equal to on it. And it's a less than, so I'm going to shade below. So that's going to be down here, shading below my line. So dashed line shaded below. X plus 4y is less than or equal to 2. And again, first thing, solve for y. Subtract x from both sides. 4y is less than or equal to negative x plus 2. Divide everything by 4. Y is less than or equal to negative 1/4 x plus a half. Okay. So my y-intercept is a half. I got a negative 1/4 for my slope, so I go down 1 right 4 or up 1 left 4. I can connect them with a line. Okay. And then from here I look at my inequality. It has the or equal to on it now, so it's going to be a solid line, so I don't have to erase. I can leave it there. And because of the less than, I shade below, which will be down here. Solid line shaded below. Three x plus y is greater than or equal to 4. Solve for y first. Subtract 3x. Get y is greater than or equal to negative 3x plus 4. Graphing that line, y-intercept is at 4. My slope is negative 3, so I go down 3, right 1, down 3, right 1, down 3, right 1. And I can connect those with a line, preferably straighter than the one I just drew. Okay. The or equal to means it's a solid line. The greater than means we shade above. So solid line shaded above. These last couple are going to be special examples. So y is less than 4. Okay? So we're going to treat this like y equals 4. That is a horizontal line. That's a constant function that we talked about last lesson. Okay? So we got a horizontal line here. From there, I do the same thing. I don't have the or equal to on it, so it'll be a dashed line. Oops. So I need to go and erase some of this to make it look dashed. Okay, dashed line. And then since it's less than, we shade below. Right. So if there's no x value, then we treat it the same way, just with a horizontal line instead of one that's got a slope with it. Last one, we've got x is greater than or equal to negative 3. Now we don't have a y value. So again, we start with the line x equals negative 3. That is a vertical line at negative 3. So that's right here. And then from there, we do the same thing. Okay? Got the or equal to, so it's a solid line. Okay? Now, this is what's going to be different. Now, greater than. Okay, there's no above or below of a vertical line. So with this, we look to shade where the numbers are greater than negative 3. Well, greater than is over to the right. Okay. So that would be greater than. Less than, we would shade to the left. Graphing absolute value inequalities, we're going to do the same thing as with graphing linear. The only difference is we'll have a V-shaped boundary instead of a line. So we've got y is less than 2 times the absolute value of x plus 3. Y is already solved for, so I don't have to do anything with that. Then I can go right to graphing my absolute value. So if you remember from last lesson, I can graph this just by using the transformations that we have. This plus 3 means we move our graph up 3. This multiplied by 2 means it'll be a vertical stretch of 2. Okay, so instead of starting at the origin like I normally would, I would start up here, 3 up. And then instead of going up 1 and over 1 in both directions, I'm going to go up 2 and over 1 in both directions. So there's my vertical stretch. And then from there, I go to the inequality. I don't have the or equal to, so it'll be a dashed line. So I go in and I make this a dashed line a little bit. There we go. And then the inequality is less than, so I'm going to shade below. So that's all this stuff here. Okay, so that would be the graph of y is less than 2 times the absolute value of x plus 3. Our next example, y is greater than 3 times the absolute value of x plus 1. Again, we look at the transformations. Plus 1 inside the absolute value means we go left 1. Multiplying the outside by 3 means we do a vertical stretch. So again, instead of starting at the origin, I'm going to move to the left 1. Start here. Instead of going up 1 and right 1, I'm going to go up 3 and right 1, up 3 and right 1, and up 3 left 1. Okay, so my absolute value will look something like this. From there, we go to the inequality. I do not have the or equal to, so it'll be a dashed line. Okay, dashed line. My inequality is greater than, so I'm going to shade above. So I'm going to shade inside of the V. So it'll look something like this. Our last example, y plus 4 is less than the absolute value of x minus 2. Go ahead and solve this one on your own. Make sure to get y by itself first before you do anything else. Then hit play, see how you did. So when you subtract 4 from both sides, you should get y is less than the absolute value of x minus 2, minus 4. That minus 4 on the outside moves the graph down 4. The minus 2 inside the absolute value moves it to the right 2. So instead of starting at the origin, we start at the point 2, negative 4. We go up 1 and over 1 because there was no vertical or horizontal stretch. The inequality does not have an or equal to on it, so it's a dashed line. And since it's a less than, we shade below. So this is what the graph would look like.